I published a new release of my Fisk AI project. It's mostly about internal changes, and I'll just talk a little bit about what's changed, demonstrate one or two things, and talk a little bit about just general points of harness engineering and features of harnesses, etc. I mentioned before the longer time goal is to be able to build operations tooling with the AI libraries that I'm using here, or I'm creating here. And so, you can imagine alert fires, a team has made a triage agent, the agent will investigate the system, and potentially reach out to Slack to the users and suggest fixes. That's the kind of eventual goal, and there's quite a lot to do there to get there. And so in today's release, you can see I've added memory and session store changes where these go into JetStream. And really for me, the messages and the records and the data types and all this kind of stuff that makes up things like memory and session store, these all has to be self-describing so that I can move it between transports, between file, between messages, between database records, between stream messages, and wherever I find a message, even if I find just one of them on Slack, I need to be able to tell exactly what this message is. And it's a real level up for being able to make things protocol agnostic and to be able to build, post-run analysis and audits and all this kind of stuff. And so I have a little agent here that's from the documentation. Actually, it tells cow jokes, and I will just show my tool output because it also tells a joke using a little tool. And I'm going to snapshot it so that it goes into the session store. Oops, checkpoint. And so we're going to see from the documentation it reads the memory, so it doesn't keep telling me the same joke, because AIs will tell you the same joke over and over again. Here's my joke, and it writes into the memory again saying, it's told this joke, so it won't tell it again. And finally, just a little interesting fact about cows. Now we can see this is running in a machine in Malta, but if I flip over to a machine here in Latvia, which is my laptop here, and I do session ls, oops, that's the wrong file. We'll see that this is the session that I just ran, and I can say session show, and that's the session I just ran. I can transcript, and there it is, with the tool outputs and everything. And so, and of course, if I run it, Fisk run, tell me a joke. Well, let me do it like this, chat. I'll do another one here. Fisk run, tell me a joke, chat. And we got a different joke, and here also a different joke. Now if I ask it, show me your fetch a new memory and show it, it will get it, and you can see there's 15 cow joke stores. And if I ask the same here, fetch the memory and show it, it may give me the list if it's clever. There we go. And so I got the list out. LLM's determinism is a bit of a joke. But these two are sharing the same memory, 15 jokes. And so memory is shared, session stores are shared, goes into JStream, and quite strong promises in the JStream store. I've used the the gas abilities to make sure that if I'm going to write a memory, that I have read that memory. So if the memory changes between turns, or since I've last read it, I need to read it again. In other words, so there's multiple agents running that don't clobber each other's updates. And the session store is concurrent safe and all this kind of thing. And so this really is not that useful for this interactive use case that I'm showing you, but down the line, if you're thinking about an agent that runs, maybe an incident happens, it gets sent a ping about outage, and it starts to triage the outage. Now, it may run through and wait for responses from workflows and this kind of stuff if it chooses. But even then, a workflow can run a long time, right? It could be hours even. And so I want to be able to take the agent that started the workflow and fully suspend it. Just shut it down. Take away all the resources. And then a background process will wait for that workflow to finish. And then when I wake up a new instance of that agent, it will rehydrate from the session store and continue where it left off. And finally, when it comes to maybe doing a human in the loop to a person over Slack, it will, once it is, do you want me to do this work? Again, just shut it all down. You're waiting for a human to do its thing. And then later on, hours later, even when the human says, yeah, do this thing, at that point, can I start up a new process, rehydrate from the stream, rehydrate from whatever the session store is, and do the work that was approved. And so in this release, I have made everything's pluggable. The memory, the session store, the connection provider, the A2A protocol is completely split up. Agent run, which is how you start and run an agent, that's completely Go, routine safe, concurrent safe, thread safe, all this kind of stuff. I've made a generic way to do extended tools using Go code. And so, in the scenario that I described about outages, I will have, tools from Go. I'm not going to call out to some shell script or whatever. To interact with the systems and the workflow tools and so forth. And all of the stuff is composable. I can put all kinds of different things in there. Even the human in the loop is pluggable. So when the agent sees the tools, he says, ask human. He doesn't know that he's running connected to Slack or connected to a shell or connected to a TUI. The harness will do the different kinds of human in the loop there. So all of these things are now pluggable and extendable. And finally, I also added a rich set of hooks throughout the agent lifecycle, where a policy engine can approve or deny actions, check what the agent is doing, see if it's trying to access secrets, see if it's trying to run destructive commands, if it's seeing output from commands and maybe there's a secret in that command output. The hooks can hide that secret from the LLM, so your system and the data inside your system can be made safe, even if you're talking to foreign or remote LLMs. And so this release is about these internal libraries, and I still have them behind the internal package, so they're only private because I'm not quite ready to make them open. But at some point soon, a goal will be to open them up. I've put up a little roadmap around what I want to work on. So we can see I want to do a graph RAG layer. Today I have a RAG system, which is quite nice. But one example where I tried to use with it, I fed into it all of the transcripts of every Criminal Minds episode ever aired. And we were asking it, for instance, to give me a list of all of the episodes where the protagonist was a female. And this was not easy because that is not a good fit for either full text search or for vector-based searches. And so with a graph RAG layer, you take the full text search, you take the vector search, and prior to ingesting the transcripts into the system, you categorize them with an LLM, you pull out basically all of the kind of metadata about an episode, and then you create graphs from that metadata, and these graphs becomes what you walk to find. Oh, okay, there's a character, Elias Voigt, find him in the graph, find all the episodes connected to him, walk those episodes, pull out the titles and the episode number, for example. And this is what a graph RAG system will enable. And so I'm researching how those things work so I can build one from scratch to understand it. Quite a bit there, especially around how we get the data into such a system and create the taxonomies. But we'll see how that shakes out. Now, having made all of the various things pluggable and suspendable and resumable and all this kind of stuff, the way that I want to get data into it is through jobs, and I have this system called async jobs, which is a asynchronous job system, right? You put the job in, it has status, it gets retried, it gets all this kind of stuff. And I want to be able to have async jobs be a way that prompts come in. So you can imagine if you have a Slack bot, Slack will send a webhook, and that webhook will go, approved on the line. And then how that actually reaches the systems running the agent is going to be via a job that says, okay, we're related to, run number 1234, and the tool call comes back, and this is the tool call results, the human in the loop tool call. And then that job will trigger the resumption of the agent, and it will continue along the line. So that the whole system is basically asynchronous jobs. My A2A system only does tool calling at the moment, and that's over request reply. I will do the actual agent to agent where two agents can prompt each other. Following in from that, I'll do a courier transport where there's identity, authentication, authorization, auditing, all this kind of stuff is there. Sitting on top of the courier protocol. And again, this is where the self-describing nature of these messages come in, because my subjects that I will use within the courier transport will be very different from the subjects that I'm using on the NAT transport, for instance, right? The entire technology tracks changes. And so the A2A system and all these kind of sessions and all this kind of stuff will survive running across different transports. And eventually I'll move this out of the internal package, and really that point where I move it out of the internal package, I need to be able to generate the incident triage bot use case as a POC using perhaps something like Kestra, which is a workflow system. There's some Korea based workflow systems also. I might use one of those. And so really this is 0.03 release. It's early days, but it's a big release in terms of code change, and it's a big release in terms of capabilities, stability, safety, pluggability, all this kind of features. And these are the building blocks that allows you to build any AI agent and make harnesses that interacts with humans and with systems in any way, and with any kind of model. Because even I've made the model extracted and through a adapter and a provider. So today I support Anthropic APIs. I can support OpenAI or any other APIs in time. Just a little thing to show. I have a plugin for Claude that can generate code maps. It's like a wiki for any kind of Go code. And here you can see such a wiki made for Fisk AI. And it shows how the different run modes, MCP, AAA, A2A, sorry, and all the plugins and adapters and so forth come together. And you can explore all the way that the configuration works, tools work, the agent loop, everything is yes. Obviously this is AI written, so some of the reading is a bit annoying, but you can check all of the way that everything works and where you can plug in hooks and all those kind of things. It's quite interesting if you're interested in how such a system would look to be written, because this code wiki is a really nice walkthrough of all of the subsystems and how those systems work and how the data flows and where the safety checkpoints are and where the humans get involved and all this kind of stuff, and how we call out to the LLM. It's apart from the now and then AI-ish English, it is a really nice document to study and work through. And we can see is all the hooks that I put in. Yeah. Anyway, so that's the current release. Probably work on a little slower pace for the next couple of weeks as I'm wrapping up my time here in Latvia and heading back to Malta. But I feel very good about where I'm at in terms of the quality and the shape and the pluggability of the code, to meet my broader goals of essentially coming to Korea Transport full A to A and eventually opening these libraries up. Yeah, that's it. Thank you very much.